On December 3rd, NASA was forced to publicly ask what is 3I Atlas looking for at Jupiter, when its body seems to have been almost completely renewed. Its luminous core is perfectly round with knife-sharp edges, the CO2 halo arranged in even layers, a slightly twisted tail trailing behind while the head remains intact. 3. I Atlas has survived a solar storm and perihelion without any sign of collapse, and its brightness flows smoothly like a carefully tuned power source. Orbital simulations show that Atlas has deliberately shifted its path by about 100,000 kilometers to aim precisely at the rim of Jupiter's Hill sphere, a gravitational harbour ideal for dropping small payloads, and the reconstructed inbound trajectory faintly cuts through the region of space associated with the 1977 WOW signal. When all of these anomalies are placed side by side, 3 at last remains a difficult puzzle for the scientific community. We will trace Atlas' journey to understand how it has changed its structure and its objective on the way toward Jupiter. In the magnified frames 3, I Atlas does not look like a worn-down comet, but like an object that has already been finished. The luminous core of 3I Atlas is almost perfectly circular, its outer edge sharp and compact, with none of the jagged teeth or smudged fringes expected from a chunk of ice and rock breaking apart. The bright central region is dense and uniform like a small glowing disk, while the surrounding halo of Atlas fades outward, along a smooth gradient with no odd bulges or sudden dents. The colour of 3 Atlas is strange as well. The core leans toward a cold white, and the outer rim carries a faint hint of green, giving the impression of controlled emission, rather than raw sunlight simply bouncing off a rough surface. Under close inspection, the halo of 3I Atlas is not blotchy, but separates into faint layers like stacked shells of gas, arranged in quiet order. In some long exposures, a thin, slightly twisted tail stretches out behind 3I Atlas, yet the head remains a balanced circle, suggesting a rigid, stable mass dragging a looser veil of material behind it. The combination of a round core razor-edge layered halo and slim spiraled tail makes 3I Atlas resemble a structure built with intent far more than a random lump of ice being sanded down by the sun. Atlas drifted against the starfield with a steadiness that felt almost deliberate while press releases focused on safer stories. The first data came not as alarms, but as quiet numbers, exposure times, pixel counts, and coordinates, all whispering that Atlas refused to blur. In long exposures from the hills of Spain, from suburban rooftops in Thailand, from frozen valleys in Norway 3, Atlas stayed razor sharp. Under windy skies and imperfect tracking, every known comet would smear into a soft tear of light, yet Atlas remained a clean circular ember. The pattern was too consistent to ignore, and still the agencies said nothing, letting Atlas appear only as anonymous dots in public databases. For the people watching in the dark, the silence felt heavier than any announcement, as if the presence of Atlas were being held behind glass. That hush would finally break when the first declassified images arrived from professional observatories, revealing that Atlas was not behaving like a dying comet at all. What had begun as a background curiosity now pressed against the edge of official attention, and Atlas was about to step into the centre of the story. The first high-resolution frame that focused on the core changed the way astronomers spoke about 3 Atlas. In that long exposure, the starfield stretched into soft trails, but Atlas remained a sharp circular point of light. Under conditions that should have twisted any normal nucleus into a smear, Atlas kept its boundary clean, as if outlined by design. Follow-up images from other observatories repeated the same quiet shock, each confirming a central glow that would not deform. Even as the surrounding coma of gas and dust billowed outward, the heart of Atlas stayed smooth, symmetric, and strangely calm. The physics of a fragile ice rock demanded cracks, jets, and scars, yet Atlas presented a face with no visible wound. Analysts tried to fit Atlas into the usual models, tweaking densities and spin rates, but the simulations all broke apart. Every reasonable comet in their code twisted under stress, while the model of Atlas only matched the data when the core was treated as rigid. The more they refined the fits, the more Atlas resembled a pressure vessel rather than a snowball, a shell built to endure. Some researchers whispered that Atlas might be hiding an engineered interior, while official summaries only spoke of an unusually stable core. The images did not prove purpose, but they refused to support randomness, and Atlas hovered in that uncertainty like a question waiting. From this point on, every new frame would be read not as a simple comet portrait, but as a diagnostic test of what Atlas really was. Around the sharp core of 3 Atlas, the surrounding glow began to tell a second quieter story. The coma did not spread in a random blur, but in soft layered shells that seemed to peel outward in measured steps. Observers who stacked multiple frames saw Atlas breathing in slow motion, each envelope of dust and gas expanding with a strange restraint. Instead of chaotic jets carving ragged fans, the halo around Atlas traced almost perfect circles as if guided by an unseen metronome. When teams compared brightness profiles from Spain, Thailand and Norway, the curves aligned, showing that Atlas was releasing material at a remarkably steady rate. Normal comets surge and sputter as sunlight bites into pockets of volatile ice, yet Atlas appeared to favour a rhythm over a spasm. In some epochs, the halo of 3 Atlas even showed hints of stratification, faint rings within rings like the growth lines of a tree. Those rings suggested Pulse's discrete episodes of outgassing that repeated across different nights and different continents. Modelers tried injecting random jets into their simulations, but only a controlled, nearly isotropic emission reproduced the calm symmetry that Atlas displayed. The more the numbers converged, the more Atlas resembled a system bleeding energy on purpose, rather than a rock simply falling apart. For listeners drifting to sleep with these images in mind, there was a gentle unease in the thought of such ordered shedding. Somewhere in the dark, Atlas moved on its layered glow, fading into the starfield, and attention began to drift toward the shape and twist of the emerging tail. The first clear view of the tail of 3 Atlas arrived from a cold ridge in Norway under thin, restless clouds. In that image, the tail did not simply stream away in a straight, obedient line from the glowing head of Atlas. Instead, the plume showed a subtle, ghostly twist, a gentle spiral threaded through the dust like smoke that had remembered a turn. Analysts measured the curve and found a slow rotation, a steady spin that should have tugged a fragile nucleus into an uneven, lopsided blur. Yet the core of Atlas in the same frame stayed perfectly round a tiny stablecoin of light at the base of the swirling wake. Computer models of ordinary comets spun at the same rate tore themselves into lobes and fragments, their simulated tails shredding under centrifugal stress. Only when the nucleus was treated as rigid as if Atlas were a solid shell or a compact engineered body did the images begin to match. The interplay was unsettlingly elegant, a flexible tail that twisted and flowed anchored by a centre that refused to deform, as if Atlas had separated the roles of skin and spine. Observers began to speak of Atlas not as a loose flock of ice and dust, but as a structure wearing a flowing cloak of material. The comparison people reached for in the quiet hours was simple and human, a dancer whose dress billows and turns, while the body at the centre remains poised. As night followed, night and more twisted plumes appeared, the sense of choreography around 3 Atlas only deepened. From that point, every new observation of the tail felt less like a random trace of gas, and more like a stress test of how strong Atlas truly was guiding the story toward questions that lay beyond mere comet physics. Across nights and weeks, astronomers began to notice something quietly unsettling about the way 3 Atlas carried itself through space. In early images, later images, and the latest calibrated stacks, the bright heart of Atlas seemed almost unchanged, as if time had skimmed past without touching it. Photometric profiles showed the coma swelling and thinning its outer veil, breathing with solar heat, but the core of Atlas held a nearly constant size and intensity. For a normal comet, each close approach, each pulse of sunlight cut small wounds, carving jets, fractures and dimples into the fragile nucleus. 3 Atlas under the same stress offered no such scars, just a smooth-centered glow that behaved more like a finished surface than a crumbling rock. When teams compared the earliest detection frames with the newest high-resolution shots, they found no evidence that Atlas had chipped, cracked, or shed any large fragments. Models that forced Atlas to act like ordinary ice and dust always ended in collapse, while only dense, rigid shells survived the simulated journey intact. Engineers who were drawn into the discussion recognized a pattern they knew from heat shields and pressure vessels, devices built to keep their shape under fire. In their quiet notes, they spoke of Atlas less as debris and more as a hull and outer skin designed to hold. For listeners drifting towards sleep, there is a strange calm in imagining 3 Atlas as something that has already passed its own trials long before reaching our sky. That sense of pre-tested endurance changed the tone of the investigation, nudging thought away from random survival and toward deliberate resilience. With that shift, attention naturally turned to the light itself, and researchers began to ask what the brightness of Atlas might be trying to say. When astronomers finally overlaid the brightness curves from different observatories, the glow of 3 Atlas began to look less like a natural blur and more like a controlled pattern. Across Spain, Thailand and Norway, independent teams measured how the light of Atlas faded from the centre outward, and the profiles almost traced the same smooth slope. Under noisy skies and different instruments, the core of Atlas still showed a tight, clean peak dropping off with a precision that surprised the analysts. In ordinary comets, local jets and rough surfaces carve bumps and kinks into these curves, small scars in the light where gas surges and fades. In 3I Atlas, those scars were missing, replaced by a gradient that resembled the output of a stable continuous source. When researchers adjusted their models, they found that they could only reproduce the observed profile of Atlas by assuming a nearly uniform emission from a compact region. That kind of regularity hinted at something inside Atlas that was regulating power, smoothing the way energy flowed into space. In internal memos, some teams quietly compared the light signature of Atlas to that of a test lamp in a laboratory, not a lump of ice shedding random fragments. The idea did not claim that 3 Atlas was artificial, but it pressed against the comfort of randomness, suggesting a level of order that was hard to dismiss. For those listening in the dark, there was a subtle shiver in imagining Atlas as an object that glowed with its own steady measured breath. That feeling grew stronger when space agencies finally stepped into the conversation, confirming the anomalies in Atlas's light, while offering almost no story to go with them. From there, the focus began to shift from the brightness curves to the human silence around Atlas, and to what that silence might be hiding. When the first official bulletin finally appeared, it read like a weather report for deep space calm and understated. The notice confirmed that a visitor named 3I Atlas had been imaged by multiple instruments, and that the data were real. Quietly, the document acknowledged a stable core and an unusually symmetric coma ticking through the same features that amateurs had been whispering about for weeks. What the bulletin did not do was offer any story about why Atlas behaved this way. No new physics, no bold proposal. In press briefings, spokespeople repeated the same careful phrases, calling 3 Atlas an interesting object and an unusual comet, then stepped back from the microphone. Charts behind them showed clean light curves and precise trajectories, but the explanations never moved beyond the safest, vaguest words. Reporters asked if Atlas might challenge standard models, and the answers flowed around the question, acknowledging anomalies without dwelling on them. For the community watching from the outside, the combination was strangely jarring, a clear confirmation that Atlas was different, wrapped in a refusal to explore how different. 3 Atlas stood there on the screen as a bright, steady point, while the language around it blurred into comfortingly bland terms. In the late hours, that gap between what was shown and what was said became its own kind of signal, a silence shaped like a question. As more data on Atlas prepared to surface, attention shifted from whether the object was real to what kind of narrative would finally be allowed to follow it. By the time the first wave of images had been compared and calibrated, 3 Atlas no longer looked like a simple visitor slipping through our sky. The sharp core, the layered halo, the twisted tail, and the smooth brightness curve all pointed to a pattern that refused to collapse into ordinary comet behaviour. Taken one by one, each detail of Atlas could be stretched to fit the edges of chance, but together they formed a shape that felt more like intention than accident. From the enduring symmetry of the core to the disciplined release of material, 3 Atlas behaved as if strength and order had been written into its skin. The light of Atlas rose and fell with a steady grace more reminiscent of a maintained source than a crumbling shard of ice. Where models expected fractures and noise, Atlas offered continuity, holding its form against heat spin and distance. For those tracing the curves late at night, the idea slowly emerged that the message, if there was one, might not come as a burst of radio or a pattern of pulses. The message might already be present in the way 3 Atlas had been built to endure, in the choreography of its glow and tail. In that reading, Atlas became less of an object and more of a sentence written in matter, drifting past our world once and only once. With this possibility hanging in the air, attention began to turn to the journey that had brought 3I Atlas here. If the structure of Atlas hinted at purpose, then its speed, its path, and its response to the forces of the sun would be the next test of what exactly we were looking at. 3I Atlas first entered the catalogue as a faint fast point near the orbit of Jupiter, just another moving line in a sea of numbers. When the trajectory was refined, astronomers realized that At Last was racing through the outer system at roughly 137,000 miles per hour. That speed alone placed At Last among the quicker wanderers ever tracked a pace more fitting for a deep interstellar traveller than a sleepy local comet. Yet on first inspection, At Last wore all the right clothes, showing a modest coma and a brightness curve that could pass for an ordinary icy body. Telescopes that barely glanced at At Last filed the visitor under familiar labels as though the disguise had worked. As the data accumulated, some analysts began to wonder whether At Last had been hiding in plain sight. The shape of the path, the timing of the approach, and the way the light of At Last rose with distance all hinted at a careful entrance. In late-night discussions, a few voices quietly suggested that 3 At Last might be more than debris, perhaps a craft wrapped in a comet's veil. The idea was framed gently as a thought experiment, a way to test how far the numbers around At Last could be stretched. For listeners drifting towards sleep, there is a strange calm in imagining At Last choosing such a familiar mask gliding through our defences of routine. If a visitor wished to cross our system without alarm, arriving as a harmless speck would be one of the oldest tricks, and At Last seemed to know that story well. The question of disguise would only deepen as At Last swept inward toward Mars, where sharper eyes waited to catch a clearer glimpse of the passing guest. As 3 At Last swept past Mars, a sharper set of eyes turned toward the visitor. The ExoMars Trace gas orbiter captured a faint stretched image, a sideways smear where At Last should have been a single point. Around that central streak of 3, At Last a few shorter slivers of light appeared like tiny scratches running alongside the main trail. To some, these slivers were nothing more than gas jets caught at odd angles, but others saw the outline of companions slipping past with At Last. Teams ran careful deconvolutions on the data, and many of the streaks around 3 At Last melted back into statistical noise. Yet 1 or 2 bright threads persisted, lining up again and again with the direction of travel that At Last was taking. That repeated alignment kept the suspicion alive that At Last might not be entirely alone in the dark. Simulations of normal jets showed branching fans and fuzzy plumes, but the surviving slivers near 3 Atlas stayed crisp and discreet. Official reports stayed cautious, calling the features possible artifacts and reminding readers how easily cameras can trick the eye around At Last. For those watching in the quiet hours, the idea of 3 Atlas travelling with a hidden convoy softened the image of a solitary wanderer. In the hush before sleep, some imagined At Last shepherding smaller instruments in its wake tucked safely inside the glare. Whether those shapes were illusions or not, the debate over escorts ensured that every later image of At Last would be scanned for intention, not just for ice and dust. When the sun unleashed a sharp, bright storm in late October, astronomers expected the first real damage to show up on 3I Atlas. The flare washed through the inner system, a wave of charged particles and radiation strong enough to strip and scar an ordinary comet. Telescopes turned back to Atlas in the days that followed, ready to watch a fragile nucleus recoil, dim, or fracture under the assault. Instead, the profile of 3 Atlas returned with an eerie familiarity. The core of Atlas held its shape, the same tight circle of light, with no signs of fresh debris or broken shards drifting nearby. Brightness curves before and after the solar storm almost overlapped, and in some bands Atlas seemed to glow a fraction more, not less. Model runs that treated Atlas as a loose body of ice, and dust predicted clear wounds, jets flaring where the surface had been stripped away. Only simulations that gave 3 Atlas a dense, resilient shell could survive the modelled blast and still resemble the calm object in the sky. For engineers, Atlas began to look like something that had already been tested against such stress, as if the journey had included storms like this before. In the soft hours of the night, there was a quiet awe in thinking of 3, Atlas riding out the anger of the sun without flinching. That unbroken composure pushed the story forward, encouraging observers to look beyond surface ice and to ask what kind of interior could let Atlas endure so completely. The next surprise from Atlas did not come from the core, but from the shape of the tail drawn behind it. In deep frames from a 2-meter telescope on a high volcanic island, the tail of 3 Atlas showed an unsettling reversal. Instead of streaming neatly away from the sun, a narrow spike of dust and gas pointed back toward the light, an anti-tail gleaming in the wrong direction. Analysts traced the geometry and found that perspective could explain some of the effect, but not the full clean spear aimed sunward by Atlas. Spectra taken at the same time added another quiet weight to the puzzle. The light from 3I at last carried signatures of nickel and iron, arranged in a way more familiar from high-temperature alloys than from frozen rubble. Those lines suggested materials that around Earth belong to engine shields and tools forged to endure great heat. In their late reports, teams suggested exotic natural origins, but the comparison hovered there close to the surface whenever at last was mentioned. For listeners lying in the dark, there was a strange image to hold on to a visitor, trailing a sunward blade and wrapped in metals we usually make not find. 3 Atlas seemed to be using the sun not only as a force to endure, but as a source to tap reshaping the usual picture of a comet into something more like a device. With each new observation, the idea grew that the motion and material of Atlas might form parts of the same design and attention, moved toward how Atlas was changing speed as it swung around the star. As Atlas curved around the sun, observers expected a simple swing by not a change in how fast the visitor ran. Before perihelion careful tracking showed 3 Atlas cruising at roughly 130,500 miles per hour through the inner system. After Atlas vanished in the sun's glare and re-emerged on the far side, new measurements climbed to about 152,000 miles per hour. In standard comet physics, that sort of boost demands powerful jets, and the models around Atlas predicted a loss of nearly 13% of total mass. Photometry and coma density estimates, however, did not show a matching thinning, and the bulk brightness of Atlas stayed stubbornly consistent. Observers also noticed a gentle change in tint, a shift in the way the glow of 3I Atlas leaned from greenish tones toward a cooler, whiter light. To some theorists, these paired anomalies suggested that Atlas might have executed a controlled burn rather than an accidental shove from random outgassing. In that picture, a compact engine buried within 3 Atlas, perhaps nuclear thermal or fission-driven, pushes outward, while the coma acts as its exhaust veil. The dusty shell around Atlas would not only hide the hardware, but smooth the thrust signature, turning sharp impulses into the quiet flow we record. For listeners sinking into the dark, there is a soft unease in imagining Atlas choosing its own speed, writing its path through sunlight on purpose. The idea that 3 Atlas adjusted its timeline through our system lends a quiet agency to the small point of light on the charts. Whether that agency is natural or crafted, the stresses of such maneuvers point inward toward questions about how the interior of Atlas is built to cope. Those questions guide the story toward density, empty space, and structure, and toward the possibility that the heart of Atlas is not solid at all. As the numbers around mass size and spin settled, a new shape began to appear in the models of 3 Atlas. Given its measured brightness and the footprint of its coma, Atlas should have carried a dense, heavy core to match the observed gravity. Yet when teams folded in the 16-hour rotation period and the estimated stability limits, the implied density of Atlas started to fall. Solid rock at that spin would demand more weight than the light curves allowed, while fragile ice would have torn apart long before reaching the inner system. The only way to keep 3 Atlas intact inside the equations was to remove matter from the middle. Simulations that carved out internal cavities, leaving a shell rather than a lump, produced objects that could rotate like Atlas without cracking. In those hollow core models, Atlas became less like a boulder and more like a vessel, a frame wrapped around empty volume. That volume inside 3 Atlas could in principle hold nothing more than void and dust, but the possibility of chambers and compartments was hard to ignore. For those drifting towards sleep, the thought of Atlas as a hollow traveller carried its own quiet gravity. It placed rooms, corridors, or tanks in the dark where only equations could reach. Whether nature alone sculpted that emptiness or some hand had shaped 3 Atlas long ago, the idea of space within space pushed attention toward the next layer of clues. Those clues would come from the way Atlas glowed against the background, and from an older mystery written in a brief signal from the sky. Years before anyone spoke the name 3. At last, a brief narrowband whisper brushed past Earth in the summer of 1977. A radio telescope in Ohio logged a 72-second spike from the direction of Sagittarius, a clean tone that never repeated. The wow signal, as it was later called, slept in the archives as a lonely question with no matching answer. Decades later, when orbital dynamicists traced the incoming path of 3I Atlas backward, their reconstructed line passed close to that same patch of sky. The track of Atlas did not sit exactly on the coordinates of the signal, but the path came near enough to demand calculation. Probability tests suggested that the overlap between the WOW region and the inbound lane of 3 Atlas was unlikely to be mere chance. For theorists already puzzling over the luminosity of Atlas, the link hinted at a deeper story tying power and trajectory together. Rough energy budgets showed that a compact reactor inside 3I Atlas could in principle sustain both a steady glow and a narrow radio beam. The idea did not prove that Atlas was designed, but it braided a forgotten whisper and a present object into one slow-moving riddle. Listeners drifting towards sleep could imagine 3 Atlas as a messenger arriving long after its first knock, now passing in silence across our charts. From here on, any attempt to classify 3 Atlas would have to reckon not only with current anomalies, but with the ghost of that earlier call. By the time the second and third rounds of observations were in, the natural comet story around 3I Atlas was stretched thin. Standard models could in theory be tuned to mimic one anomaly at a time, but they tore when asked to hold all of Atlas's behaviours together. The survival through the solar storm, the stable core, the anti-tail pointing sunward, and the controlled-looking acceleration all demanded extreme unlikely parameters. Simulations of a purely natural 3I Atlas required a nucleus losing tens of billions of tons of mass each month to sustain the observed tails and speed changes. Such shedding should have left Atlas surrounded by a dense fog of debris and a wildly fluctuating coma, neither of which appeared in the data. Even generous attempts to invoke rare compositions and violent past collisions could not easily align the endurance of Atlas with its delicate signatures of control. In meeting rooms and late-night calls, some researchers kept the label comet on 3 Atlas only because no better category officially existed. Others began to speak of Atlas as a boundary case, an object sitting on the frontier between known physics and some uncharted design. For listeners lying awake in the dark, there was a quiet tension in realizing how much had to go right by accident for Atlas to be just debris. That uneasy realization did not end the debate, but it shifted its center. From this point forward, every new observation of 3 Atlas would be weighed not only against comets, but against the emerging possibility that purpose, not chance, shaped the journey ahead. At first, the plotted path of 3 Atlas looked like a graceful curve through the inner system, a simple swing past the Sun and away again. Early runs of the orbit showed Atlas marching along a track carved mostly by familiar gravity, brushing past the orbits of Mars and Jupiter, before fading into deep space. As more tracking points came in, the fitting software adjusted the line with each new night, tightening the uncertainty around where Atlas was truly headed. Then a small stubborn kink appeared in the solutions for 3I Atlas. The refined trajectory of Atlas no longer passed through the empty lanes expected from the first models, but drifted by roughly 100,000 kilometers toward the orbit of Jupiter. On the scale of planetary distances that offset sounded minor, yet for navigation, it was the kind of deliberate nudge that separates a miss from a meeting. When dynamicists extended the updated path forward, the new curve of 3 Atlas brushed the outer edge of Jupiter's hill sphere, the wide invisible bubble where the planet's gravity holds sway. The hill sphere is a kind of quiet harbour in space, and the numbers now said that Atlas was steering straight for its rim. With each additional night of data, the error ellipse around 3 Atlas shrank, and the projected point of closest approach clung to that gravitational shoreline. Monte Carlo trials suggested that an interstellar object wandering at random would land on that narrow band by chance only once in tens of thousands of tries. For observers trying to sleep, the odds made it hard not to feel that 3 Atlas had selected a rendezvous, not stumbled into one. That realization bent the story away from simple drift and toward intent, and it led directly to the next question. What kind of passage through heat and tide would Atlas have to survive in order to keep that appointment with the giant planet waiting ahead? As 3 Atlas fell inward toward the Sun, models predicted a punishing trial of heat and gravity. The orbit of Atlas brought the visitor into a zone where ice-rich bodies usually sputter crack and sometimes vanish from view entirely. Observers anticipated that the passage would finally tear open the surface of Atlas, revealing the fragile core that comet theory demanded. During the days when 3 Atlas slipped behind the Sun from Earth's perspective, telescopes on our side could only wait. The predicted perihelion for Atlas was a narrow window when tidal forces and radiation peaked together, a moment when many comets lose their shape. When the visitor emerged again from the glare, the first recovered images looked almost like copies of the frames taken before the plunge. The core of 3 Atlas remained circular and calm, the coma modest and centered with no dramatic fans or fresh scars. Brightness profiles of Atlas before and after perihelion overlapped so closely that analysts had to search for differences with magnifying tools. Subtle shifts in trajectory hinted that 3 Atlas had adjusted course in the very phase when chaos should have ruled. For dynamicists, the combination was deeply anomalous, a survival without visible cost paired with a precise change in direction. Only models that treated At Last as a robust shell with controlled energy release could reconcile endurance and maneuver in the same passage. In the quiet of late night, 3 At Last began to feel less like a victim of the sun, and more like a seasoned traveller using the star as a turning gate. That sense of practiced resilience carried the narrative forward. If 3 At Last could pass so close to the central fire and come away composed and redirected, the next question naturally shifted to scale. What kind of body could be so small in its core and yet command such a vast structured envelope on the road toward Jupiter's domain? Measurements of the visible core suggested that 3 At Last was far smaller than the first impressions from the sky. When high-resolution images were corrected for glare, the central glow of At Last pointed to a nucleus less than a kilometre across, comparable in scale to a city district. For an interstellar traveller, 3 At Last seemed almost modest at its heart, a tiny ember wrapped in a much larger display. Around that small centre, instruments traced a vast coma stretching hundreds of thousands of kilometres from the core of At Last. In some reconstructions, the gas-rich envelope of 3 At Last reached spans greater than twice the diameter of Earth. The contrast was striking, a near miniature seed at the middle of an enormous hazy shell. Standard comet models strained under this imbalance because a nucleus as small as the one in At Last should not so easily sustain such a huge structured cloud. Random venting from a speck of ice would normally create ragged, uneven plumes, yet the coma of 3 At Last kept returning to a rounded, symmetric shape. The effect was like seeing a candle flame somehow casting the footprint of a bonfire with 3 At Last holding its form at the centre. For listeners drifting towards sleep, there was a quiet fascination in imagining such a tiny core commanding such a wide sphere of influence. The scale mismatch around 3 At Last hinted that mass alone was not telling the whole story. That hint pushed attention toward the composition and behaviour of the surrounding envelope, and toward what kind of atmosphere could be so large and yet so controlled. Spectral scans of the halo revealed that 3 At Last was wrapped in an atmosphere dominated by carbon dioxide. In the models, the CO2-rich coma of At Last extended roughly 350,000 kilometres from the core, a sphere so large that Earth could vanish inside it. For a nucleus as small as the one pinned at the centre of 3 At Last, such a vast envelope should have been chaotic and ragged. Instead, density maps showed the gas around 3 At Last thinning in smooth gradients, with few of the clumps and voids expected from random venting. In some reconstructions, the CO2 distribution around At Last hinted at faint layers like stacked shells, rather than a single shapeless fog. The numbers suggested that whatever was releasing gas from 3 At Last was doing so in a steadier, more measured way than simple sunlight on ice. Observers began to wonder if the coma of At Last functioned less like a leaky cloud and more like a controlled shroud, a regulated skin of gas around the traveller. If that picture was true, 3 At Last might be using CO2 as both protection and camouflage, turning a volatile atmosphere into a structured buffer. Requests for sharper images of the CO2 halo around At Last often returned blurred or delayed results, officially blamed on technical limits and processing time. For those listening in the dim hours, there was a quiet tension in that combination of smooth structure and imperfect views. 3 At Last seemed to be wearing an engineered mist, a vast cold breath shaped just enough to conceal details. That impression drew more attention to the tail itself, and to the possibility that the wake of At Last carried clues its surrounding haze was trying to hide. High-resolution images of the tail of 3 At Last slowly replaced the earlier grainy smears with sharper, more revealing shapes. Where observers expected a simple fan of dust trailing away, the wake behind At Last showed subtle variations in brightness and width, like a code written in light. Closer analysis revealed zones where the tail of 3 At Last narrowed into a tight filament, then broadened again with surprising regularity. In standard comets, solar wind and random jets carved tangled shifting structures into the tail, producing kinks that wander from night to night. The patterns behind 3 At Last, however, repeated with a quiet persistence, as if the same forces were being applied in the same way again and again. Some regions appeared cleaner, almost swept, as though At Last had brushed its own path through the thin dust cloud it created. Dynamicists began to treat the tail of 3 At Last not just as a byproduct, but as a sensor, a visible record of how the traveller interacted with the surrounding wind. In that view, every bend and thinning in the wake of At Last became a clue to the balance between pressure spin and controlled emission. Readers and listeners sensed a shift from seeing 3I Atlas as an object leaving a trail to seeing the trail as part of the design. For those drifting towards sleep, the long pale wake of 3I Atlas could feel like chalk lines on a cosmic blackboard, drawn for anyone patient enough to follow them. As more data arrived, the focus moved from individual details to a wider frame, the path of Atlas. The survival near the sun and the peculiar grace of the tail all converged on the same destination, drawing attention toward Jupiter and the strange harbour that waited there. For many dynamicists, the growing precision of the orbital fit made 3 Atlas feel less like a wanderer and more like a guided guest. The map showed a crowded solar system where countless paths are possible, yet the chosen lane of Atlas threaded toward a very specific gravitational landmark. Jupiter, with its deep well of mass and wide network of moons, stood directly ahead of 3I Atlas like a waiting harbour. In simulations that scattered virtual comets through the same region, only a tiny fraction ever brushed the narrow ring that Atlas was aiming for. Those runs treated 3I Atlas as a passive stone, and most of the digital visitors either plunged too close to the planet or sailed far outside the hill sphere. The real path of Atlas, by contrast, held to a corridor that passed near the edge of that influence zone, as if the traveller preferred the pier to the shoreline. Avi Loeb and others began to ask why 3 Atlas would favour that rim, where gravity is strong enough to catch small cargo but gentle enough to release it again. In that picture, Jupiter becomes a natural spaceport, and Atlas becomes a carrier using the giant planet as a staging ground. For listeners lying in the dark, the idea that 3 Atlas might be navigating a known network of gravitational harbours reshaped the scene above their heads. The trajectory of Atlas no longer felt like a simple curve, but like a route chosen from a chart older than our species. Once that possibility entered the discussion, every future move of 3 Atlas was watched for signs of timing and coordination. From there, attention turned toward the specific date and distance of the coming encounter with Jupiter's domain, and to what kind of exchange might be possible along that invisible border. On March 16, 2026, projections placed 3I Atlas skimming just inside the fringe of Jupiter's hill sphere, about 53 million kilometres from the giant's cloud tops. In navigation terms, that corridor is an ideal insertion lane, slow enough for gentle capture, fast enough for a clean exit, as if Atlas had threaded a needle of gravity. Mission planners on Earth quietly noted that a craft in the position of 3 Atlas could release small payloads there with minimal fuel. Those fragments would drift into long stable orbits around Jupiter, while Atlas continued on unburdened. For listeners drifting towards sleep, the image of 3I Atlas dropping silent seeds into the Jovian harbour adds a soft, unsettling grace to its flight. If such a transfer were part of the design, then Atlas might already be treating our system as one stop on a much older route. With that possibility in mind, attention turns to the larger pattern of anomalies, and to whether they converge on a single coherent story about what 3 Atlas really is. Seen together rather than in isolation, the scattered clues around 3 Atlas begin to rearrange themselves. The rigid core of Atlas, the layered CO2 shroud, and the disciplined tail all point toward a structure that favours order over accident. The survival of 3 Atlas at perihelion, the controlled-looking acceleration, and the hollow core models hint at deliberate engineering rather than a simple shard of ice.